Okay, here's warm-up 7R. All right, so let's graph these rational functions, irrational equations. So I'm going to look for intercepts and asymptotes and maybe holes. So looking at this one, I can see it's the same degree on top and bottom. I also see some trinomials, so I'm going to start by factoring those to see if to see what happens. So let's see the numerator here. Just going to do a little diamond problem here. I'm looking for two numbers that add to -1. Same two numbers multiply to -6. So a 2 and a -3 is my winning combo there. Okay, in the numerator, or sorry, the denominator, let's see, -1, -2. Looking for two numbers that add to -1, multiply to -2. That would be 1 and -2. Okay, so looking at this, there's no reducing that I can do, but that's good to know. Okay, and the factored version actually comes in useful too. So let's start with the vertical asymptote. Or sometimes there can be two vertical asymptotes. So that's going to come from undefined x values. It's going to be things that I can't plug in for x because they'll give me a 0 denominator. Okay, so what I can do is just set the denominator equal to 0 to find those asymptotes, and this is where one of the places where the factored version will come in handy. So I know that denominator looks like that factored, so neither of these, this whole thing can't equal 0, right? And that means that neither of the, if I use the zero product property, x plus 1 can't equal 0. So x can't equal -1, but then also x minus 2 can't equal 0. So x can't equal +2. So I've got vertical asymptotes, vertical lines, two different ones at -1, like so, and also at +2. Okay. All right. So horizontal asymptote is going to come, but since I've got a balanced equation, same degree on top and bottom, I'm going to use y equals, that'll give me a horizontal line, and I'm going to use the leading coefficient of the numerator, which is 1, over the leading coefficient of the denominator, which is also 1. So I've got a horizontal asymptote at y equals 1. So let's put that in. Okay, and from there on out, finding the intercepts is going to just be plugging in zeros. If I want the x-intercept, I'm going to plug in 0 for y. I'm going to use the factored version here because I would wind up factoring it later on anyways. So okay, so I've got that. Now if I wanted to solve this, I would multiply both sides by the denominator, and then 0 times both of those is going to equal 0. When I multiply both these binomials by 0 on the left, it'll just equal 0. So I'm really just setting the numerator equal to 0 to find the x-intercepts. In this case, there's two x-intercepts. Okay, so this is going to lead to x equaling -2 if I use zero product property, and +3. All right, let's put those in. So -2, +3. Okay, so I'm starting to get an idea what this looks like. Let's check the y-intercept. So y-intercept, plugging in 0 for x. I'm going to use the original version, but you could use the factored one as well. But I'm plugging in 0 in all of those x positions. Okay, and there's not much left there except the -6 and the -2. So that simplifies to y equals 3. Okay, so y equals 3 is my y-intercept. Okay, now I have a pretty decent idea of what's going on. I think there's going to be a curve like this, a curve like this. It's a little bit hard to tell in the middle because this asymptote just guides my curves at the far ends of the at the far right and the far left. So in the middle, I'm going to get a curve here of some sort. Sometimes the curve will kind of look like a parabola that would go back up, but sometimes it can actually cross over the horizontal asymptote just in the middle part, in between those goalposts. So one way to figure it out is to start plugging in x values if you didn't have a calculator. Now, I'm going to just graph this on a graphing calculator and see if everything I've done jives with what the calculator says. So I'm going to the y equals button. Don't have anything in there, but if I did, I'd clear it. Okay, so x squared. Oh, I forgot. So I'm going to put the whole numerator in parentheses so my calculator doesn't get confused. So x squared minus x minus 6. Okay, let's close those parentheses. Then I'm going to hit divide. And now my denominator, I'm going to put that in parentheses too, just to be safe. X squared minus x minus 2. Okay, close the parentheses. So I've got it plugged in there, and the y equals screen. Once you get it in there, hit graph. Okay, I have like a 10 by 10 graph here, but if you have some different view, this is the standard zoom. So if you hit zoom and go to zoom standard, that'll give you this 10 by 10. Okay, you can always zoom out or zoom in from there. But this is looking pretty good with what I have here. It doesn't show me the intercepts, but it does work with the intercepts that I have drawn already. So as I suspected, there's going to be a curve down here, something like this, fitting in with those intercepts, and one here as well. What I wasn't quite sure about is the part in the middle, and it looks like I've got some sort of a parabola-looking curve in the middle there. It looks like it doesn't cross over, but sometimes it might do that. Okay. All right, let's try another. So here I'm going to factor the numerator again. So let's see, 5 and 4. Okay, so 1 and 4, right? So this factors into x plus 1 times x plus 4. Okay, I can't reduce here, so this isn't just going to be a straight line with a hole in it, because it doesn't reduce farther than that. So let's start with vertical asymptotes. I'm going to find those in the same way I did on this first problem. I'm going to set the denominator equal to 0. So this is undefined x values. It's things that will give you a 0 denominator. So x can't equal -2 because that would give me a 0 denominator there, right? Let's put that in. Okay. Now this one doesn't have a horizontal asymptote because it's a higher degree on top than it is on bottom, and it doesn't reduce. So this one's going to have a slant asymptote. So to find that, let's do the division that's suggested here. So I'm going to think of the trinomial divided by the binomial in the denominator. I'm going to use synthetic division here. So I'd put a -2 in this little box. Okay, I'm going to pull down the 1, multiply, add, multiply. Okay. And then I'll build this back. So this is going to be x plus 3, and this would be my numerator of the remainder. The denominator is what you're dividing by. Okay, and with the slant asymptote, you just throw away the remainder fraction. So this is my slant asymptote, because when you plug in really large things, this is going to be almost 0. Okay, it's going to become insignificant. It's going to be approaching 0. So that means the curve is going to get closer and closer to this line. This line is going to be my slant asymptote then. So that has a y equals x plus 3. Has a y-intercept of 3 and a slope of 1. So up 1 to the right one, up 1 to the right one, and down 1 to the left one. Okay, and there's my slant asymptote. And now I've got some guides for drawing my curves. So I'm expecting to get curves either in these two corners or in these two corners. To figure that out, let's find the x and y intercepts. Okay, x-intercepts come from plugging in 0 for y. And then, if I had 0 over here for y, I'd clear the fraction by multiplying both sides by x plus 2. So x plus 2 times 0 would be 0. So you can just set the numerator equal to 0. That's what I'm going to do as a little shortcut. Okay, so I could use the trinomial, but I would just end up factoring it anyways. Okay, then I'll solve for x, so this would lead to x equal -1. This would lead to x equaling -4. So -1 and -4. Okay, so I'm thinking now it's going to be these two sides. So let's see what happens with the y-intercept. I'm expecting to get a y-intercept below this slant asymptote, so it stays in this corner, but let's see what happens. So y-intercept, I'm going to plug in 0 for x. Okay, and all that's left is the 4 and the 2. So y equals 2. Okay, and then hey, I've got a pretty good idea of what this curve looks like. And I should get kind of a mirror image in that opposite corner as well. I don't have a second point to guide me, but you know, you could find a second point by plugging in -3 for x and seeing what happens. But yeah, it's going to look something like that. And that's it, and I'll see you next time.